Hey, physics friends. I want to take you through the worksheet that I assigned to you. Sine, cosine, tangents, law of sines, law of cosines, practice number 1. I'm going to apply this algorithm to solving all 4 of these problems. A lot of people always say, Mr. Hare, I have no idea. No idea. And I get that. It's the first time you've seen a problem like this. But watch how I beat these 4 steps like a dead horse. Look for diagonal vectors. Sometimes there are diagonal, sometimes they're not. And if there's no diagonal, then you're just going to skip over, then you're going to go right to number 2. And then you go to number 3, use the Pythagorean theorem, and number 4, using inverse sine, cosine, or tangent to find your angle. So let's get started. So here's the first question up here. It says, an individual walks from home. They walk 35 miles west, turn 90 degrees to the right, walk 17 miles. They stop there and make a campfire. A, what's their displacement? B, in what direction do they have to get back if they want to walk home? And then see if their brother was at home and they wanted to walk to the person, what specific direction do they want to walk? So the thing is, with specific directions, you can't just say northwest. You got to be very specific. You got to tell me 30 degrees north of west or 60 degrees west of north. You can't just go saying general directions. So let's get started here. It's always helpful to make a picture. 35 miles west, 90 degrees to the right, so that right is this way. And then you're going to walk 17 miles. It's good to try to make this to scale as possible. At 35 is almost twice 17, so I tried to make that arrow twice as much as the 17. The better you can be to scale, the better your chances are going to be. So try to make these roughly to scale when you're making a picture. What's your displacement? Your displacement is this right here. The difference from where you started, home, to where you're at now. That's the campfire. So this one, we're going to look at those, look for diagonal vectors. There are no diagonal vectors in this one. So we're going to skip right to number 2. Add all the x components and y components. There's only one x component, 35, and there's only one y component, 17. Pretty easy to add those together. 35, 17, there's no adding whatsoever. So, next part. Use the Pythagorean theorem to find the resultant. So we're going to go 17 squared plus 35 squared equals d squared. So using the Pythagorean theorem, d equals 38.9. I'm going to save you writing it down because I'm going to assume you can all do the Pythagorean theorem. Part B, in what specific direction must they travel to get back? I'm going to go using inverse sine, cosine, or tangent. So for me to get back home, I'm right here. So getting back home is this angle for me. So I'm going to say the tangent. I'm just going to use the tangent because 17 and 35 are already there. So theta is going to be the inverse tangent of the opposite over the adjacent. So that angle right there ends up being 64.1 degrees. So that's 64.1 degrees, and this is, to me, I'm here. This direction is south to me. So this is east of south because I'm standing at the campfire. If my brother wanted to go from home, so my brother's here at home, he wants to go this angle right here. Let's call it gamma. I think that's what that is. So if this is 64.1, this is the complement. So remember how all angles in a triangle, especially this is a right triangle, have to add up to 180. So this is going to be 28.1. Oh, 25.9. 25.9 degrees. Now, for my brother, this direction is west. That's north of west. So remember, getting those directions is super important. Understanding what is north of west versus west of north, which is why I gave you all those to begin with. And here we are putting them into practice. Let's go to the next question and see how we use those exact same steps. Let's talk about number 2, friends. I don't know why my webcam isn't working here, but we'll just pretend like it is, and you can listen to the soothing sound of my voice without seeing me. It's probably better than you have to look at me. It says an individual walks 22 kilometers. This is east. They walk 22 kilometers at an angle of 23 degrees south of east. They then turn 90 degrees to the left, and here's where it gets kind of tricky. When you go 90 degrees to the left, do I go this far? Do I end up south of east? Do I go a little bit further? Do I end up exactly on the line? Or do I end up going further still and end up above the line? Gosh, the only way to do it is if you have yourself a scale model. So you take out a ruler and you make a scale and you actually get a protractor to draw 23 degrees. None of us want to do that. So here's what you do. You just take a wild guess. And I'm going to guess 16 is almost 20. I'm going to guess that. That's just my best guess. I think 16 is almost 22. They're about the same length in a way, but a little bit shorter. Here we go. What's their displacement? So what we're going to do is we're going to go to these rules here, and we're going to step our way through them. So number one, look for diagonals. We've got two diagonals in this problem. Let's break them into their x and y components. So we're going to jump back here, and we're going to take each of these. This one's 22. This one's 16. We're going to break each of these into their x and their y components. Now, it's really important to draw your arrows in the correct way. This 16 is up and to the right, so just make sure that you have an arrow to the right, which is your x, and up, which is y. It's important to have those. So we know that this angle right here is 23 degrees, so it makes finding x and y using sine and cosine pretty trivial. So if we use our sine and our cosine to find that, I'm going to save you guys doing that. This turns out to be 20.3. And the y component turns out to be 8.6. If you can use different colors, it's really helpful for these problems to kind of keep yourself organized and neat. Now, back to this angle right here. This angle is kind of tricky. This angle represents this angle right here. So from a little geometry, if this is 23, so is this. If that's 23, this is a 90 degrees, so they have to all add up to 180, so I know that this has to be 67 degrees. So this angle right here, 67 degrees. I'm going to try to keep myself a little bit neat, because this problem is pretty complex. So using sine and cosine, I get 14.7 over here, and I get 6.3 here. So I've just broken down into our x and y components, and now it says replace. Here's what I mean by replacing them. This 22, what if I told you instead of walking at a diagonal 22, you walked south at 8.6 and then you walked east at 20.3? You still end up in the same place. I've replaced that. And what about this weird angle? What if I told you I kept on walking east at 6.3 and then I walked north at 14.7 and I replaced that one? Now you can tell. You can tell. Remember my initial question, like, did I end up on the south side or the north side of that east line? Look it. I walked south 8.6 and I walk north 14.7. So now you know you ended up on the north side of that. So here's I've just replaced them all. Next step, add. Add all the x components and add all the y components. And we just did that in our brains right now. When I added up all the y components, I was negative 8.6 because it's 8.6 down plus 14.7 north. So that's a positive 6.1. And if I add, this is the Greek letter sigma. It just means to add them up, add all the x things. A positive 20.3 because I'm going to the right, east, plus 6.3. That's another one going east, so that equals 26.6. So really what I did in this whole problem, I ended up walking to the right 26.6, and then I walked up 6.1. So, last step, use the Pythagorean theorem. We're going to use the Pythagorean theorem to figure out exactly how far I am from home. So I go a squared plus b squared equals c squared, and that turns out to be 27.3 kilometers. That's part A. How far away am I? 27.3 kilometers. Now part B wants to know, sorry, I'm going to try to clean this up a little bit because I like to keep it a little bit neat. How do I get home? Now remember, when you were walking, you walked down here and then you walked up here. So here's where you're at. You're at the end right now. You are at the end of the line and you want to walk home. So here is north. Here is west. You got to walk southwest to get home. So what I'm going to do is I'm going to find this angle right there, theta. And I'm going to do that by using the inverse sine, cosine, or tangent to find that. So I'm going to use tangent because that's my favorite. Because tangent is the opposite, which is 26.6, divided by the adjacent, 6.1, and you get 77.1 degrees. Now, this is west of south, because here's south, and you're measuring west of it. West of south. You could also say 12.9 degrees south of west, and that just represents this angle right here. That's a completely legit angle measure to find, and that would also get you home. So there's the answers to this. And remember, I walked my way through. This is the hardest problem in my opinion. Look for diagonal vectors. Replace them. Add up all the x and y components. Use the Pythagorean theorem, sine and cosine. And that's kind of what I did for this whole thing. Final answer, 27.3 kilometers away at an angle of 77.1 degrees west of south. Individual walks 24 miles south, and then they walk 22 miles in a direction of 30 degrees west of south. So here's 22 miles, and this angle right here is 30 degrees west of south. How far away and what direction do you want to go if you want to go back in a straight line? So let's start again. Look for diagonal vectors and replace. So there is a diagonal vector here. It's this 22. I'm going to take this 22 and I'm going to break it into its x and its y components. This being 22, and then this angle is 30 degrees. I'm going to use sine and cosine here. So to find my x and my y components. So if I take 22 times the sine of 30, you end up with 11. Fun fact, in a 30, 60, 90 triangle, the shorter leg is always half of the hypotenuse. And then I'm going to use the cosine. I'll take 22 times the cosine of 30, and that turns out to be 19.1. This one's a little bit pictorially a little bit easier for me to replace. So I'm going to bring this one over here, 19.1, and I'm going to bring this one over here, 11, and I'm going to replace it. I'm going to get rid of my 22. And now you can see the right triangle that this forms. So I can use the Pythagorean theorem. See where I'm going? I got a big old right triangle right here. when I add up all the x and the y components to then use the Pythagorean theorem, all I'm really doing is building towards a one large triangle to do the Pythagorean theorem on. So if I add up all the x's, there is only one thing in the x direction, and that's a negative 11. I'm going to add, it's negative because it's going to the left. I'm going to add up all the y things, and they're all negative too. Negative 24 minus 19.1, and that equals 43.1. So when I'm doing my triangle, it's 43.1, and it's pointed down, and it's 19.1 pointed to the left. So using Pythagorean theorem, a squared plus b squared equals c squared, that turns out to be 44.4. 44.4 miles. And in what specific direction must they travel to get back home? So when you walk south and then you end up walking west, to get home, you're going to have to walk north and east. So let's find this angle again. Step 3, use inverse sine and cosine or tangent to figure out your angle to go home. So this angle is going to be the inverse tangent of 43.1 over 19.1. And you end up, when you do that, to be 75.7 degrees. So this is 75.7 degrees. Now, this direction is north. This direction is east. That's going to be north of east to get home. That's what you could also, again, you could also use like 14.3 degrees east of north in your answer, depending upon kind of what you found. Let's go on to our last one. An individual walks 13 kilometers north, and they turn 140 degrees to the left. And this is left. It really is going to mess you up when I send you south and then I tell you to turn to the left because it's the opposite. You'll see. 140 degrees, and I go 16 kilometers. That doesn't, see how that's not really quite to scale? Because 16 should be bigger than 13. And just for my own humor, this angle right here is 50 degrees. Because if that's 140 from north, then that has to be 50. Okay, what's your displacement and in what specific direction? So again, we're going to go back to these ones. Look for diagonal vectors. In this case, there's only one diagonal vector, and it's the 16. We're going to bring that diagonal vector over. We're going to break it into its x and its y components. I don't know if you've noticed, but I always do x in the green and I do y in blue just to help keep my brain straight when I go to add all the like terms together. So this being 50 degrees, and this is also 16 kilometers. I'm going to use the sine and the cosine to find that. So using the sine, 16 times the sine of 50, you end up with 12.3. And 16 times the cosine of 50, you end up with 10.3. We then replace, right? So we're going to get rid of this. We're going to get rid of all this, and we're going to replace that with this vector right here and this vector right here. Oops. I lost my y value, which I think is 12.3. Now, I'm going to add up all the things in the x direction. There's only one thing in the x direction, and it's negative 10.3. I'm going to add up all the things in the y direction. There are two. I have a positive 13, up 13, and then a negative 12.3. That is equal to a positive 0.7. So I actually end up replacing these right here, this 13 and this 12.3. So what in reality, when it all said and done, I end up going to the left 10.3, and I end up going north 0.7. So this is I can now find my resultant. I have added all the x's and y's, and now I'm going to use the Pythagorean theorem to find my resultant. So a squared plus b squared equals c squared, and with all of my significant figures, this ends up being 10.3 kilometers. How far away are you? 10.3 kilometers. That's kind of weird. And then what direction must you travel to get back? So here, when it's at the end, here you are, and you want to get back home. Find this angle. That angle, I'm going to use inverse sine, inverse cosine, or inverse tangent, right? The opposite over the adjacent ends up to be something like 86.1 degrees. So this is 86.1 degrees, and this direction is south to me. So that's 86.1 degrees east of south, or 3.9 south of east. So there you have it. I did all 4 of these questions with this algorithm. Look for the diagonal vectors. That second question wasn't really good. I wish I would have put that second question at the very end, because it's there's 2 diagonals. It gets tricky when you start having lots of diagonals, but look for the diagonal vectors. Break them all into their x's and y pieces, and then add them all up. And then use the Pythagorean theorem, inverse sine, inverse cosine, inverse tangent. Don't panic if you went through this and you didn't quite understand what you were doing. This is the way every chapter goes. And I hope that you're in the idea now that, like, the first time I see this stuff, super panic inducing, you have no idea what's going, but hopefully you've seen over the past 3 chapters that I can get to the place. I can get there. Fail forward. Fail early, fail often, reflect, fail forward. Good luck, kids.